Hi and welcome. This video today from Heartricity is going to cover the basics of sensitivity. Sensitivity is very important when we're talking about programming pacemakers and ICDs. Now, if you're relatively new, which you probably are, to device monitoring, you may want to check out our video on sensing concepts. Sensing and sensitivity go hand in hand when you're checking devices, so you may want to check that out. All right, so let's get started. In this video, we're going to use a Biotronic programmer, but the concepts we're going to show are totally applicable for all of the four companies' devices and their programmers. So we're going to see here a couple of sets of red arrows. And the top arrow is pointing to a P. That P is on the top of the horizontal line there. And so the top of that horizontal line is the atrial markers, and then below that horizontal line are ventricular markers. So we see a P on the top and an S on the bottom. So we're pacing in the atrium, and in this case sensing in the ventricle. So that S stands for a sense. And again, in this video, we're going to just concentrate on the ventricle to illustrate sensitivity, but the concepts apply totally to the atrium as well. So the other thing we want to show here is that vertical two-headed arrow. Okay, so it's pointing upward to another sense, an S, and then the bottom portion, the bottom arrow, is pointing to that little yellow signal there, which is a ventricular signal. And what that's telling us is that our marker is lined up appropriately above that yellow ventricular signal that's being generated in the ventricle. Okay, so the other thing we want to point out is that these yellow signals that I keep referring to as yellow signals on the bottom line, that horizontal line is the ventricular channel. And those yellow signals that are being pointed at by those arrows are called R waves. And as I mentioned before, we're not going to cover atrial sensing today, but the same concepts do apply. And these atrial signals, which would show up on that blue line above the yellow ventricular channel, those are called P waves. Okay, so now let's start to talk about sensitivity. You see that in this example, the device is programmed to 2.5 millivolts. We also see that all of the R waves, or again, those little yellow signals, have an S above them if you look up vertically from those signals. So based on all these signals being marked with an S, we know that all of these R waves must be greater than 2.5 millivolts, our current sensitivity setting. Okay, now we're going to show what happens when we change the sensitivity to a different number. So we're going to change it from 2.5 to 6.5 millivolts. So here's something that's a little confusing. I know it was for me anyway. And that is when you increase the sensitivity number, like we just did, going from 2.5 to 6.5, you're actually making the device less sensitive. Again, making the number higher makes the device less sensitive. So what do we see here after the change to 6.5 millivolts was made? So the first thing we see on the top there is that there are no S's on that ventricular, below that horizontal line. Those S's, we now see P's for pacing. Okay, so then the next thing we see that's circled there are intrinsic QRSs. Intrinsic meaning the heart basically beat on its own. So it was an intrinsic beat, an intrinsic QRS. Again, those are circled. And then you see the arrow pointing down to the R wave, that yellow signal, and we've underlined those R waves in blue. So the key takeaway here is that since we made the device less sensitive by going to 6.5, the device is now not sensing these R waves. We say in this case the R waves are undersensed. And since our sensitivity is set to 6.5, we know that these R waves must be less than 6.5 millivolts.
If the R waves were greater than 6.5, you would see the S's. So we've inserted those S's with the blue boxes around them with the arrows pointing down to indicate that, again, if the R waves were greater than 6.5, they would be marked by those S's.
Okay, so here's another way to look at sensitivity. We've changed our sensitivity setting back to 2.5 millivolts. Again, now we've made it more sensitive compared to 6.5 millivolts. Now I'm going to place a horizontal bar on the screen there. One thing to note here is that the signals on the bottom are a little taller than we saw on the previous two screens, but that's just because we've gained up those signals. The actual R waves have not changed, but for illustrative purposes, it kind of makes it a little clearer. So this bar, again, you're not going to see this on a programmer, but we're going to think of this as the sensitivity setting. And if the R waves are taller than this so-called sensitivity bar, then the device will sense that R wave. But if it's shorter than the sensitivity bar, the device will not sense it. So in this example, we can see that each of the R waves is a little bit quote-unquote taller than the sensitivity bar of 2.5 millivolts. And again, we can say that the R waves are greater than 2.5. So one last time, we're going to go back to 6.5 millivolts. Again, first of all, just to reinforce, we can see those S's are now P's. As you can see, there's no S above the R waves. Now we're going to insert the sensitivity bar, as I'm going to call it. Again, this is just to give you kind of a mental image. You will not ever see a sensitivity bar on your programmer screen. Please do not ask your EP about a sensitivity bar. It's just sort of a teaching tool. But we can see that the bar, in this case, is above each of the R wave signals. So the signals aren't tall enough or big enough to be sensed. And since our sensitivity is at 6.5, again, we can say that the R waves must be smaller than 6.5. Now, the way in which the device actually senses these signals is a lot more complicated than, quote, how tall the R waves are. Now, when we get a little more advanced, we're going to learn about terms like auto-sensing and also how ICDs sense. But that's a little later. Today we've covered undersensing in this video. There's also oversensing, which we'll cover in another video. So, several key takeaways from the video. When increasing the sensitivity number, for example, going from 2.5 to 6.5 in our example, this decreases the sensitivity of the device. Or, as can see on this slide, if you go from 4 to 5, again, you're going to decrease the sensitivity. Also, you're going to hear when a device undersenses, it overpaces. And we saw this in this example. Also, when we look at oversensing, we'll see that the result of oversensing is underpacing. Okay, that's going to do it today for sensitivity. I hope this was helpful and look forward to talking to you again soon.